Hi, welcome to this presentation on motor drivers. Whoa, this was created for Electronics Spec 2023 by the spec head, Raghav. So yeah, this was the presentation I was supposed to make as part of my job testing. And now that that's over and advanced electronics training is inbound, I guess it's good that y'all have some revision on this topic. So yeah, I'll be going through this. Firstly, here's a brief lesson overview. You can skip this, it's not that important actually. Okay, so do you have a... Yeah, fun fact, almost none of them brought laptops. Okay, here's the framework we'll be using for everything. We'll be going through the theory, the application, and then the tinkering. Stage 1, theory. What exactly are motor drivers? Motor drivers are electronic components, and they act as an interface between microcontrollers and motors. It allows the microcontroller to send a signal to the motor driver, so it can control things like speed, direction, acceleration, etc. I've asked ChatGPT to explain this to me the way a pirate would. So yeah, let's see this. Miharti, a motor driver be the magic box that helps me ship's motor run like a charm. But effectively, if you read this yourself, it has a pretty accurate description of what a motor driver is supposed to do. Because it tells the motor how fast to spin, which way to turn, and how hard to push, depending on the signals it receives. So why would we actually need motor drivers? Can't regular motors do all of that itself? Let's look at this circuit. Problem. In this basic circuit, Arduino is connected properly. But the issue with this is that the motor can only go at one speed, which is high, and cannot go in reverse. So how do we make it do the opposite? How do we make it go in the opposite direction, for example? Solution? We use this, a H-bridge. So this diagram looks very complicated and scary with all those funny symbols and words. It's just this. Don't worry about it. It is just this. So let's go through this diagram a bit. We have the power supply and the ground, the V plus and V minus. Then we have the motor, which is the actual motor we are dealing with. And then we have the control switches. These control switches help determine the direction of electrical current. So in forward flow, switch S2 and S3 are supposed to be closed. And in this case, it goes through the wire from right to left. And as a result of this, the motor has to spin in a certain direction. This allows the motor to, as we have mentioned, spin in a certain direction for a certain speed for a certain amount of time. In backward flow, it's the reverse. You open S2 and S3 and close S1 and S4. Effectively, we're doing the same S shape but in reverse. So now, because it passes through the motor in the opposite direction, this results in the motor spinning the opposite way. And because of this, you can get the motor effectively to reverse direction. That's quite cool, right? Now, how do we stop it? If everything is open, again, physics, it just stops. Makes sense. So what happens if we completely close off one side? In both of these scenarios, we've completely closed off the left and right side respectively, and in this case, it completely dodges the motor. It avoids it completely, and as a result, the motor does not do anything. This is called the brake stage. Beyond this, there's one more, which is, what happens here? What do you think happens here? If you close the first two, and you basically don't exactly let the circuit work. Well, do not do this. It's a short circuit. Effectively, it's going to blow up the motor because you're gonna have electrical current rushing at both sides at the same time, and this is not good. If you like having intact fingers, please don't do this. So yeah, in a circuit diagram, if you have a plus and a minus, which is effectively the current going in that direction, then it can be anti-clockwise or clockwise, and if it's the other way, it can be clockwise or anti-clockwise, depending on your configuration and the motor itself. Now, how do motor drivers work? It's because of this thing called pulse width modulation, PWM. You'll be learning this quite a lot. So, motors effectively use PWM because you can see by the diagram itself how duty cycles work. When you have more energy given to a motor, it does more work. And this is not done, right? This is not done by increasing the voltage. It is done by increasing the duration of a high voltage. So it's very simple. You can see based on the diagram how exactly PWM can work. You just need to know the greater the duty cycles percentage, the more work the motor is doing in a sense. Now here are some types of motor drivers. There are many different types that are available for brush DC, brushless DC, steppers, and each of them have to work with a specific kind of motor, and they have different specifications and features depending on the motor that it's intended to control. Okay, pit stop. Why did I make this? Whatever. Pit stop A. Okay, stage 2, apply. So this is the one we're going to be working with, which is the MX1508. Again, as you can tell, there's a VS for modular power input, a GND for ground, in 1 to 4 for inputs, and out 1 to 4 for outputs. And yeah, you just need to be able to match them up, then you should be fine. I came across these, and I don't know. Making this lesson was pain, but it's okay. I still managed to somehow get the English version of the content out, right? So, yeah. Now, for forward movement. If you want to do forward movement, you have to have one going at low and one going at high for your first input and second input. The reason for this is because of the configuration you can see on the right. And similarly, for backward input, it should be the exact opposite, where one would be high and one would be low. Again, very standard stuff. And as you can see by the green arrow, the motor will rotate in a different direction. Now for stopping. If both of them are low, then everything's going to be open, it stops. Makes sense. Logical. And what would you expect this to be? Remember the illegal thing I told you about? The one that you should not do? What happens if you do this? Well, the manufacturers knew that you were going to be a stupid boy and do something like this. So what they ended up doing is breaking. So normally when you do this kind of thing, you'd expect a short circuit to take place. However, there are internal logic gates that prevent this from happening. So this effectively sets up for the previously mentioned break paths, which completely stop any short circuits. So yay, your fingers won't be blown off. Yeah, so here's a few cheat codes for the direction. Pit stop D. Oh my god. Yeah, I guess I was not really much of a funny person back when I was starting out. Okay. And thinker. Yeah, this stage is just a circuit and some challenges. Firstly, the motor going at full speed. This is an example code. Then we have the motor going backwards at full speed. Another challenge. Setting up this circuit using a potentiometer and using a potentiometer to vary the speed of a motor. Yeah. Now, using a button, this is how a button would be used in a regular Arduino circuit. And then the next challenge, which is only if you have time, is how you can use two buttons to toggle between two speeds the motor can run at. If you want, you can try these challenges yourself using the simulator. I recommend you do. It is quite useful to know how these work, especially for the potentiometer stuff. That's all, folks. Hope you learned a thing or two. Okay. Yeah, you don't need to do this feedback form. That was back when I was spec hit testing. Okay, bye.